Assalamualaikum warahmatullahi wabarakatuh. Hari ini kita akan sambung kita punya chapter 4. Alright, which is improper integral. Okay, kita dah tengok L'Hopital rule for 0 over 0. Okay, so hari ini kita akan tengok L'Hopital rule for infinity over infinity. Okay. Alright. So, this L'Hopital rule akan implement again if the answer is infinity over infinity. Okay, so if the numerator and denominator both tends to either positive infinity or negative infinity. So if fx over gx is infinity over infinity or negative infinity over negative infinity. Alright, so we will use L'Hopital rule. Okay, so this is the formula. So we need to find the differentiation of the fx and also differentiation of the gx. Okay, so here is the example. Okay, let's say we need to find the limit of x tends to infinity. Okay, x over ex. Okay, so our fx is x and our gx is ex. Okay, so if we substitute the value of infinity for both functions here, so it's become infinity over exponent infinity, which is equal to infinity over infinity. So in this case, we cannot use this answer. Okay, we need to apply L'Hopital rule, which is we need to find the differentiation of f and also the differentiation of g. Okay. So what is the differentiation for x and what is the differentiation for ex? Okay, so the differentiation of x is equal to 1 and the differentiation of ex is exponent x. Okay, so exponent x, and then we need to substitute the infinity. So we will have 1 over exponent infinity, which is exponent infinity is equal to 1 over infinity. Therefore, it is 0. So the answer, the new answer for the limit of x over ex is 0. Okay, now we look at the next example. Let's say we have the limit x tends to infinity and the function of fx is ln x power of 1000 over the gx is ln x. Okay, so if we substitute the infinity into the x, we will obtain ln infinity over ln infinity, which is ln infinity is equal to infinity. Okay, so in this case, both fx and gx also infinity. Okay, so we will obtain like this, ln infinity over ln infinity, which is infinity over infinity. And we cannot accept this formula, this answer. We need to use L'Hopital rule. Okay, so how we want to solve this? Again, we need to find the differentiation for the fx and the differentiation for gx. Okay, so ln x 1000, after the differentiation, we will obtain 1 over x ln x. Okay, so the ln x after the differentiation, we will obtain 1 over x. Okay, after we simplify, we will obtain 1 over ln x. Why? Because this fraction we will multiply at the top here and we can cancel out x and x. So that's why we have 1 over ln x. Okay, and then we need to substitute the limit. We will obtain 1 over ln infinity, okay, which is equivalent to 1 over infinity and which is equivalent to 0. So this is the answer for this limit. Okay, so basically how I obtain the differentiation for the f. The ln x 1000 is equivalent to this one. How I get this? Okay, so first we need to use, basically for this case, we need to use chain rule. Okay, so for chain rule, first we need to define the first substitution, which is u. So we substitute this ln x 1000 with u, which is ln x 1000. Okay, so ln x 1000 here, we can change to 1000 ln x, which is we need to bring the degree of the x here in front. Okay, so this is the property for the ln. Okay, so this one ln x 1000 is equivalent to 1000 ln x. Okay, and then of course after the substitution of u, we need to differentiate it. Okay, du dx, we need to find du dx. Okay, so 1000 remain. Okay, so the differentiation of ln x is 1 over x. Okay, next we need to find y ln u, which is this one is y. So since we already changed ln x 1000 into u, so the remaining function is ln u. Okay, ln u. So we need to substitute with subject to u, dy du. So ln u, the differentiation of ln u is 1 over u. Okay, for chain rule, to get dy dx is equal to dy du multiply with du dx. Okay, so how we want to check whether this function is correct or not? So if we cancel out the du, we will get back the dy dx. Okay, so next dy du is 1 over u, du dx is 1000 1 over x. Okay, so this u we just substitute back with the u. Okay, 1000 ln x. Okay, so we need to multiply with 1000 1 over x. So we need to simplify this. We might cancel out the 1000. So the remaining function is 1 over x ln x. So this is the differentiation for ln x 1000. Okay, so this differentiation we substitute it into the limit here, which is for the f prime x. Okay, so that's it. Thank you very much.